Good morning, everyone. Can you hear me?
Yes,
Good morning,
doctor.
doctor.
All right, so now let's begin our tutorial section. Okay, so today we'll be trying exercises of okay, tutorial chapter 3. Okay, so in my lecture on Sunday, I have talked about the chain rule and implicit. So we'll be trying this exercise today. Okay, so we'll begin questions number 5. So just now I have tried question number 5A and 5B with section 3. So you can refer to the notes that I already shared in the author. So I will try now with you question number 5 C. Okay, wait a minute. 5C. Question 3. Okay. So go here. So this is wait for. So wait for tutorial with the section 4. So alright, so now we are doing exercise 5C. So solve the following problem by applying the chain rules. Okay. Chain rule. Okay. So you will apply the chain rule. You will apply the chain rule when you found that in the main functions, the variable in the main function that are represented by the other functions. For example, like this case, the main function is z equals to x squared plus y squared. Right, this is your main function, and your main function has variable x and variable y. So for this variable x and variable y, it is represented by the other equation respectively. So f equals to r cos theta, y equals to r sine theta. So this is the equation for the x and y. So now we are required to find the del z, del theta, and also the del z, del r. So this is your task. So the first things when you want to apply the chain rule is you must form the chain rule equations. So how to form? So I will talk about it again. How to form the chain rule equations? First of all, write down what you wish to find. Which is the del z, del theta, and then examine your main functions, and check how many variable is there. You have two variable, that is the x and y. So you are going to have x sections here, del z, del x, and you are going to have a y section here, del z, del y. So this is the first, and after that, copy back. If this is x, write down here x. And this is, if this is y, write down again del y, and then copy back the terms over here, theta. So it will be del theta, and it will be del theta here. So this is how you form the chain rule equations. By looking at this chain rule equation, you will be clear what kind of partial differentiation you need to perform. You will know you need to find out del z, del x, del theta, del z, del y, and del y, del theta. So this is your task. So let's find it for the del z, del x. So what will be the del z, del x? Very easy. It is 2x. You can just write down. And for the del z, del y, it is equals to 2y. 2y. Whereas for the del x, del theta, you need to differentiate with respect to the theta. So r will be a constant, cos will be negative. Negative sine theta. And for the del y, del theta, okay, del y del theta, it will be r cos theta. Okay, so this is the way you do this thing. Right. Okay, so next we just put them inside your equation, your chain rule equations. Del z del theta, so it will be 2x, okay, multiply with negative r sine theta plus 2y multiply with the r cos theta. Okay, and next replace the x and y with its equations. So meaning that you have 2x is the r cos theta, okay, and you have a negative r sine theta plus 2y. 2y, why you have r sine theta multiply with the r cos theta. Okay, so you will have a negative 2r squared cos theta sine theta plus 2r squared cos theta and sine theta. Okay, and you see it will be equals to 0. 5, yeah, it's 0. Yeah, it's 0. Okay, you can cancel it. So this is your del z del theta. Okay. Right. Okay, so we move on to the next one. We have to find out to the del z del r, right? Del z del r. So form the equation again. Del z del r. Okay. So check your main functions. Your main function has x variables, so you will have x sections. And it also has y variable, so you have y sections. And copy back. Okay, copy back. Okay, there are y, copy back. And then follow what you want to find. So it will be there are. Okay, so we don't need to repeat these two things. Okay, we just need to find out what is the del x del r. Okay, so del x del r will be equals to cos theta. Okay, very easy. And for the del y del r, okay, it will be equals to sine theta. Okay, so we're going to replace it here. So it is 2x cos theta, okay, plus 2y sine theta. Okay, just replace it back to your equations. And now replace your x and y with its respective functions. Okay, r cos theta, so we have a cos theta plus 2, y is r sine theta, and you have a sine theta here. Okay, so you can actually take out these two r, and this one will be cos square theta plus sine square theta. Okay, and this one is equal to 1. So your answer is 2r. Okay, 2r. Is that okay?
Okay, Doctor.
All right. So we move on to the questions D. Okay, question D. So what is question D about? Okay, question D now we have this long function. Okay, question 5D. Yeah, let's do this question 5D. So 5D, okay, you have a main functions which is z equals to ln. Okay, you have a x squared minus 2y, right? You have main functions. And on the other hand, your x is represented, your x is represented by u plus v. And your y is represented by exponent v. Okay, so you write them out. and they want you to find the del z, del u. Okay. So first step, again, form the equations. So the equation won't be always the same because it depends on the how they name the variable. So you need to know how to do it. You cannot memorize. Okay, you need to learn how to actually come up with the chain rule equations. So the del z, del u, look at the function z. It has two variables, x and y. So you have a del z, del x, and del z, del y. Okay, two sections. Okay, and moving on is copy. Copy the del x, copy the del y here, and then look what they want. Okay, they want the del u, so you just copy the del u. Okay, copy the del u. Now we find out four of them. Okay, so the first will be the del z, del x. Okay, so it is a long functions. When you differentiate long function, you will get 1 over x squared minus 2y. Okay, this is for the long function. And after that, okay, you need to differentiate, okay, the term in the bracket with respect to the x. Okay, with respect to the x, meaning that you will get 2x. 2x minus 0, so it's 2x. So this is your del z, del x. Okay. As for the del z, del y, so similar step. Okay, you will still get this 1 over x squared minus 2y. And the term over here, you have to differentiate with respect to the y. So it will be 0 minus 2. Okay, so it will be minus 2. So this one is the del z, del y. And then we move on to the del x, del u. Del x, del u is easy, right? Okay, you have 1. And for the del y, del u, you will have, there's no u, right? So the whole thing is a constant, so it is 0. Okay, you don't have the u, so it's a constant, so differentiate will be 0. Now put them back to your main functions of chain rule. So it will be 2x over, okay, x squared minus 2y, okay, multiply with 1. Okay, as for the other term, because it is 0 over here, so it will be 0. Okay, it will be 0, so I don't write it out. So here you can change all the x, y, okay, to the variable u and v. So it will be 2x is u plus v. Okay, divide. Okay, you have an x squared, so it's u plus v squared minus 2y. Y is exponent v. Okay, you can just leave your answer in this way. So del u, del z, del u. Okay, you can just leave your answer like this. So this is del z, del u. Next, am I too fast?
Okay, Doctor.
Okay, so we move on to the del z, del v. Form the equations. Okay, so equation z has two variables. That is the x and y. Alright, two variables. And copy the del x and copy the del y. Then check what you want. You want a del v. Okay, del v. Okay, so this is the equations. Okay, for the del z, del v. So we have performed the del z, del x, and we have performed the del z, del y. Now we'll be focused on the del z, del x, del v. Oh, this one is so very easy. It's equals to 1. And for the del y, del v is equals to exponent v. Okay, it's the same thing. And in fact, when you differentiate the v, you get 1. Okay, you get 1 here actually. So we can actually exclude this 1 now. Okay, right. So copy back. Del v will be equals to minus 2y, right? 2y. So this is the del z del x. Del x del v equals to 1 plus, this one will be negative 2. Okay, negative 2. Negative 2 over x squared minus 2y and exponent v. Is it correct? Let me check. Del z del y negative 2. Okay, right. So you can now replace it. 2u plus v over, in fact they are the same, you can write them together, right? Okay, so it's u plus v square minus 2 exponent v. Okay, then this one would be minus 2 exponent v. Okay, you can factor it out, or if you want to leave it like this, no problem, it's also fine. So this is the concept for the chain rule. Are you okay with the chain rule?
Okay, Doctor.
Yeah. So I think I will skip to the next questions. You can try yourself and compare your answer with the answer provided. Okay, for the chain rule. So I will move into the next questions. Question number 6 we already tried during our lecture. So we go to 7b. Okay, we'll go to question 7b. So I've tried question 7a with section 3. Okay, you can check the solutions. So for the question b, okay, if z is implicitly defined as a function of x and y by this, x squared plus y squared plus z squared equals to 1. Okay, they want you to show that. Show that means you need to prove. You need to prove that when you put the x multiply with the del z del x plus the y, you multiply with the del z del y, okay, it will be equals to z minus 1 over z. And you need to show that this is true. Okay, you need to prove. So when you need to prove, it means that you need to find out this first. Okay, you need to find out this one first. So look at the z functions. Okay, so the z functions, the z is here. And in fact, you can split it away from the x and y. Okay, right? When you rewrite it, it will be equals to 1 minus x squared minus y squared and square root. So you can split it. Okay, you can split the z away from the x and y. So in this case, you don't need to apply the implicit partial differentiations. You can just differentiate as usual. So you need to find out what is the del z del x. Okay, so the del z del x is equals to, okay, you have a 1 over 2, right? So 1 over 2, 1 minus x squared minus y squared, okay, and negative 1 over 2. Okay, now you need to differentiate with respect to the x. You get negative 2x. Okay, so this is the del z del x. So you could simplify it. You get negative x over 1 minus x squared minus y squared and square root. Okay, this is the del z del x. So for the del z del y, okay, del z del y, it will be quite similar. You have 1 over 2, 1 minus x squared minus y squared, negative 1 over 2, and then differentiate with respect to y. You get negative 2y. Okay, you can cancel it. You get negative y over 1 minus x squared minus y squared and square root. So this is del y. Now you try to put them accordingly to what the question wants you to do. Okay, so x multiply with the del z del y. So it will be negative x over 1 minus x squared minus y squared. Okay, just put them together. and put them together, and plus to y, okay, multiply with the del z del y, so it will be equals to this. So 1 minus x squared minus y squared, right? Okay, so now try to prove that it is equals to z minus 1 over z. So let's try to simplify. Okay, so here you get negative x squared, right, negative y squared, square root. Okay, this is plus, right? Okay, so it's 1 minus x squared minus y squared, square root. All right. So if we look at this part, okay, it is equals to z, right? See, it is equal to z. So I will replace it with z. Okay, I will replace with z. Okay, how about this? How I'm going to relate it with z? Okay, if z squared equals to 1 minus x squared minus y squared, okay, so minus z squared plus 1 will be equals to minus x squared minus y squared. Okay, so we can put this thing to replace it. Okay, so it will be equals to z squared plus 1 over z. So if you split it out, okay, if you split it, it will be equals to z plus 1 over z. Okay, so you have proven. So you have proven that when you do that, you can find the same thing like what the question mentions. Okay, so you have to write down proven. Is that okay?
Yes, Doctor.
Alright, so we can try one more example. Let's try the questions 7C. So don't worry when you see like quite complicating equations saying what about the Laplace equation, blah, blah, blah. In fact, they just want you to show, they just want you to prove that it is equal to 0. So we look at question C. So you have z equals to exponent x sine y plus exponent y cos x. So you have to show that, okay, del square z over del x square plus del square z over del y square equals to 0. Okay, so what is the meaning of square square here? Meaning that after you have performed, okay, the del z del x, you have to take this answer and perform one more time. Okay, differentiate it one more time with respect to the x. Okay, so let's do it. Okay, same applies for the del z del y. You have to perform 2 times differentiation with respect to the x and y. Okay, first of all, let's find out what is the del z del x. Okay, so del z del x, look at the first term. Exponent term will stay. Sine also will stay, right? Okay, because it is a constant. Okay, so for this cos x, okay, you make it become, so exponent y will stay. So this one will become negative sine x. Okay. So now we differentiate second time with respect to the x. Still the same thing, exponent x. Right. Nothing to do with this one, the same thing. Okay. Now differentiate with respect to the x. Sine will give you cos. And you have a negative. Okay, you put a negative here. Negative exponent y cos x. Okay, so this is the answer. Now we move on to the del z, del y. Differentiate with respect to y. Okay, differentiate with respect to y. Let's see, y. Okay, so exponent x will be a constant. You copy back. Sine will become negative cos y. Okay, right. And plus, okay, so now exponent y, when you differentiate with respect to y, you still get exponent y. So the cos x is a constant. You just write down again. Now we perform the second time. Differentiation with y again. Okay, y. So negative remain, exponent x remain because they are constant. Okay. Wait. This one is positive, right? Sine will become positive. Okay. And then cos, stay. Right? Okay. So cos will become negative sine. Negative sine y. Okay, negative sine y. And this one remains the same thing. Okay, in fact, you can check already. This thing is going to cancel out with this one, right? And this thing is going to cancel out with this one. Okay, so you can prove that. Oh, write down. Okay, I think better to write down. So exponent x sine y minus exponent y cos x plus minus exponent x sine y plus exponent y cos x, okay, is equal to 0. So you can write down it is proverb. So you can cancel it, sine y, okay, cancel them. Okay, so you have proved that they are 0. Okay, so this is about the question 7. Okay, now we will move forward to the questions for the implicit partial differentiations. Question number 8. Question number 8, implicit partial. So I want to move to question D first. Question number D. Okay, just now I tried with ABC with section 3. Now we go to questions D. So this is your function given. Okay, so now you have to find the del z del y and also del z del x. Okay, so to find these two, okay, maybe you will say that z is over here. I can just bring the others to the right hand side and then perform the differentiation as usual. Yes, you can do that. Okay, no problem. But here, I want you to solve this question by using the implicit. Okay, by using the implicit. What I mean is, what I mean just now is you can actually rewrite. Okay, you can rewrite it to be z equals to pi plus sine x squared minus x squared minus y cubed and divide negative 2. Okay, you can solve using this one. But now I want you to solve using the implicit. Okay, so if you want to solve using the implicit, first of all, you must know, okay, what is the equation that you have to use. If you want to find the del z del y, first of all, put a negative. Okay, put a negative. And then put a f. Okay, functions. So these functions, okay, you have to differentiate with respect to y. Okay, following the notations, and then divide with the function differentiate with respect to the z. Okay, so this is the del z del y, and for the del z del x, same thing. You have to put a negative and then functions differentiate with respect to the x, divide function differentiate with respect to the z. Okay, so this is how you perform using the implicit partial differentiations. So we will try to find it. So the first thing you might be asking, what is the f? Okay, so to find the f, first of all, you have to move whatever at the right side to the left. Okay, meaning that it will be equals to x squared plus y cubed minus 2z minus sine x squared minus pi equals to 0. So the right hand side now has become 0. So your f will be this. Okay, this one will be your f. Now you have to perform fx, fy, and also fz. Okay, so let's do for the fx. So the x will be equals to 2x, right? This one is 0. This one also 0. This one sine will give you cos x squared. And the x squared itself, you need to differentiate with respect to the x. So you get 2x and minus 0. Okay, minus 0. So this is the fx. And for the fy, okay, so it will be 0 plus 3y squared minus 0 minus 0 and minus 0 because they don't have the y term. Okay, and lastly, it will be fz. Okay, so fz, see, it will be 0, 0 plus 0 minus 2, okay, minus 0 and minus 0. Okay, just negative 2, you see, just negative 2, see, negative 2. Okay, now we arrange them back, del z, del x. Okay, so the formula is minus fx. So minus 2x minus 2x cos x squared. Okay, divide with negative 2. Okay, so maybe you want to cancel the negative 2. Okay, you can cancel it. Okay, you can cancel it. Okay, so this one, if you want to simplify again, you can cancel this one. Or you write it as x1 minus cos x squared. Okay, so this is your del z del x. Is it correct? D. Negative 2. Why there's no negative 2? Why there's a negative? I think the negative is already cancelled out, right? Yeah, I copied the wrong questions. Oh, it's a plus 2, plus, okay. So I copied the wrong question, so this is plus. So this negative is still there, okay. I copied the wrong question, so this is plus 2, okay, plus. Okay, plus. This is plus also. Okay, so this is the del z, del x. Now we move on to the del z, del y. Still have a negative. So your del y is, del y, fy is 3y squared over 2. Okay, so you have a negative. So this is the answer. So the answer over here will be the same as the answer if you perform this. So let's check, is it the same answer? If you have to perform the del z, del y, you are using this one. So this will be the constant, not constant, only this one. So you will have a negative 3y squared over 2. Yeah, it's the same thing like this one. Okay, so if you can solve by using so no, it's optional for you whether you want to solve by using implicit or the normal method. Okay, but for simple equation you can solve by using normal method. Okay, but for complicated one, for example, like the question 8c. Okay, we go to question 8c. Okay, for question at C you have 2x squared z power 4 minus 5 ln xy z squared equals to 4z. Okay, so for this one, we have no choice to split the z away from the x. We cannot split. Okay, so for this kind of functions, we must use the implicit partial differentiation rules to solve it. Okay, now for this one, let's say when we want to find the del z del x, okay, we have to write out the equation. It will be fx over fz. And for the del z del y, okay, it would be minus fy over fz. Okay, so this is the functions. Now we need to find the fx. Okay, but before that, we need to define what is the f, right? So f will be moving whatever at the right to the left. So your f will be 2x squared z power 4 minus 5 ln xyz squared minus 4z. Okay, so this one will be your f. Okay, will be your f. Move whatever at the right to the left. Now, find out what is the fx. Differentiate with respect to the x. You have 4x z power 4. And then for the ln, it will be 5 over x, y, z squared. Okay, so for this x, y, z squared, you need to differentiate with respect to the x. So you have y, z squared. And this is 0 because it doesn't have x components. Okay, so this you can cancel out. Right. So this is your fx. Following will be your fy. So let's find the fy. So no y, 0. So this one will become negative 5 over ln xyz squared. Okay, xyz squared. Okay, now differentiate with respect to the y. You have x z squared, right? And this one still 0. So now cancel out. Cancel this thing and cancel the x, right? Okay, so you got this. So now fz. So fz differentiate with respect to the z. You have 8x squared, it's constant. So z will become power 3 minus 5 over xy z squared. And then differentiate with respect to the z, you get this, right? And then 4z will give you negative 4. Okay, negative 4. So now try to simplify this as y. Okay, now put them back. Negative fx. So fx is 4x z power 4 minus 5 over x. Okay, you can just leave it like this. Okay, no problem. Just leave it like this. And for the fz equals to x squared z power 3 minus 10 over z squared and minus 4. Okay, you can just leave it like this. So this is your del z, del s. Okay, negative fy is negative 5 over y. Okay, don't confuse, eh? Negative 5 over y. Divide. Okay, so if you wish to cancel out this negative, you can do so. You can cancel out. Okay, so this is the del z, del y. So any more questions for these implicit partial differentiations? You want to try one more example? Are you there?
Yes, doktor. Boleh, boleh.
Okay. So we try one more example. Maybe we try the questions 8A lah. Okay. Question 8A. Okay. So let's find the del z del x. Okay. Okay. Write the functions. And then write down what is your f. Okay. Over here you have nothing. Okay. So nothing to move to the left. So your f will be equals to z squared plus z sine xy squared. Okay. So now we'll be doing fx. Sine will become cos. Now differentiate the term with respect to the x. Okay, so this is fx. So we'll do the fy, okay, because later on we will use it for the del z del y, okay, fy. So fy still 0. So same thing. Right. Now differentiate with respect to y. Okay, so you will have 2xy. Different thing. Okay. Lastly will be your fz. Okay. 2z plus sine xy squared. Okay. Now we put them inside. Negative fx. So I have a zy squared cos xy squared. This is my fx. Divide with my fz. 2z plus sine xy. Just put it back. Very simple. As for the del z del y, minus or negative fy. Fy will be 2xyz cos xy squared. This is your fy. Divide 2z plus sine xy. Okay, so this is how you find the del z del x and also del z del y. Right? Okay, so that's all for the differentiation, partial differentiation of Chern-Roth and implicit. We're now moving on to the graphs. We're now moving on to the tutorial 4.1, which is about the double integral. So we'll be trying these questions. Okay, but before that, do you need a break of 5 minutes? You need a break?
Yes, doktor.
Okay, so we will break for 5 minutes. So we will come again 11:50. Okay, right. Continue this question 1 later on. So 5 minutes, yeah. How come only Charles responding? How about the others? Are you there too? Raise your hand. Give me some response. Some smiling face. Whatever. All right. So enjoy your 5 minutes. We'll come back later. Okay. Okay, everybody. So let's try this exercise 2B. Okay, you can get this exercise tutorial questions in WhatsApp group. Also in the author, I have shared it. Okay, so we'll be looking at question number 1, double integral as area of regions. So as what I have explained to you on Sunday, we can use the double integral, okay, to find the area of a region. Okay, so this is what we have talked about on Sunday. Let's see Sunday what happened. Okay, Sunday we learned about I first introduced you about double integral, how to solve double integral. Okay, you have to solve the inner part first, and after that proceed to the outer part. Okay, and you can use calculator, whatever, right? So all these questions, their interval has been given. So interval, what is interval? Interval is this one. Okay, the interval. Okay, this is the interval. So interval are all given, but when you want to find the area, okay, question won't give you the interval. You have to find the interval based on the information given by the questions. Like in this example, they ask you to solve this one. They just tell you that the R, the interval, is actually a region of a triangle. So you have to apply vertical strip technique or horizontal strip technique in order to solve it. Okay, I've explained to you all these things, horizontal and vertical, blah blah blah, and so on. And if you want to find the area, this is the formula. Okay, so the way to define the interval is exactly the same like the previous example. Okay, after you find it, you proceed with the double integral, you can find the area of a region. Okay, so in today's exercise, okay, which is this one, okay, we'll be sketching the region R first. Okay, we sketch first, and then after that, we will find the area. Okay, we will find the area which is covered by the region, the covered by the regions. Okay, so question 1A and B I've tried with section 3. So I'll proceed with questions 1C and 1D. Okay, 1C and 1D. So let's move it. So now is a double integral. Double integral as area of region. Okay, so sketch the region out and close between. Okay, and close between that means that this region is covered. Okay, it's covered by all these lines. Okay, it's covered by all these lines. So let's see what are the lines. So for question 1C, you have a line. Okay, so line y equals to x. Okay, so it is a straight line. And then you have a line y equals to 3x. This is also a straight line. And one more, x plus y equals to 4. Another straight line. So you have 3 straight lines which cover or enclose the region. So you need to plot out these 3 lines before you identify the regions. So let's plot out together these lines. Okay, so this is the 2D graph. So y equals to x. Okay, so if you don't know how to plot this one, okay, all these they are straight lines. So the equation of straight line is mx plus c. So for y equals to x, okay, this straight line has no c, right? Has no c. The c equals to 0. Means that this straight line is touching. It's touching the origin. Yeah, it's touching the origin. And look at the m. Okay, the m over here is a positive value, meaning that this graph will be going up like this. Okay, so you can sketch this graph going up like this. Okay, so this one is your y equals to x equations going up. Okay, going up like this. Next one will be y equals to 3x. Okay, quite similar to the x, right? But 3x, meaning that the m is 3. Okay, so if you have no idea how to plot this one, maybe you can assume a point for yourself. Okay, so you know that for this y equals to 3x, the c is still equal to 0, meaning that it's still touching the origin, but you need one more point to actually help you to draw a graph. Okay, draw a graph, draw a line. So maybe you can give it a value of for example 2. If your x equals to 2, it can be any value, okay? Your y is equals to 6. So maybe you give yourself, if this is 2, if this is 2, 2 is here, for example. So y is 6. 6 might be here. Let me adjust a bit. Y equals to x. So 6 might be here. So you can use this point and this point to plot a line. Okay, something like this. Okay, so you found that this line is more slanted, lebih condong, okay, daripada yang this one, okay, slanted, okay. 3x, you label it, and then you have one more, which is x plus y equals to 4, and in fact this x plus y equals to 4, when you rewrite it, it will be y equals to negative x plus 4. So you have an intersection point C here, which is 4. Just now I said this is 6, right? So might be 4. 4 is here, okay? So we'll be covering here. This is 4. So this line will be touching this point, and you need one more point to plot, right? So the M over here is negative. Negative means that it is going down. So when it go down, it will touch your axis X. Okay, so might be you want to try replace what happened if your y equals to 0. So when your y equals to 0, your x is equals to 4. So you can say that again, okay? 4 will be here. So you can make a line, okay, touching these 2 points. Okay, touching these 2 points. Now you can see where is the region. Region that is covered by all these 3 lines. Okay, so this one will be your region. Can you see this region? A bit small. Oops. A bit small. So it's this one. This is the region. Alright, this is the regions. Okay, the regions. Oop. Oop, oop, oop. Okay, so this is the regions. Okay, now you have sketched the region. Now you need to find out what is the area of this region. You need to find out what is the area. Okay, so what is the equation to find the area? So the area is equals to double integral 1 MdA. Okay, so this is a fixed equations. So your job now is to define what will be the interval. Okay, so your interval you have to define using horizontal strip technique or vertical strip technique. Yeah, you can pick one of them. Okay, so let's simply pick one. Okay, look at this one. Maybe I'm zooming a bit. Okay, if I want to solve by using horizontal, what will happen? So, let me try. So I will just draw a vertical line because I want to use the vertical strip technique. So this is my vertical strip. You can see this is my vertical strip. So my vertical strip, when I move it to the minimum, okay, I move it to the minimum, it will stop here. Agree? So it will, is it too thin? Okay, I will stop here. At this position, your x is equals to 0. These positions. And when I move this side, okay, to the end, I might stop here. Right. So I might stop here. So these positions, I have no idea what is the x, but I know that this is the intersection point between y equals to x and one more, x plus y equals to 4. I know this is the intersection point. So in order to get this x value, you have to solve simultaneous equation. You can solve using your calculator. Okay, try to learn how to solve. And if you want to solve manually, okay, you can try to link this one, link these two together, meaning that you replace the x here. Okay, so it will be x plus x equals to 4. So 2x is 4 and the x equals to 2. Okay? Oh, this one agak-agak lah. So this one, okay, this one will be equals to 2. Okay, write down here 2. Okay. Okay, this one is equals to 2. Okay, so your x will be from 0 to 2. Now, let's see what happens if I putting myself inside. Okay, not never mind. Let me draw again. Okay. Draw again. Oh. Pick this one, pick this one. Oh, this one is not suitable. Draw again. Something like this. Okay. So this is x equals to y. Okay. Draw extended. Okay. So now, if I am inside this horizontal streak, okay, when I refer down, I see this line, right? This line is equals to, let's see, y equals to x. And when I refer up, I see another line, okay, another line, which is y equals to 3x. Okay, y equals to 3x. This is y equals to 3x. And bottom is y equals to x. Okay. Now I try to check again. When I put my vertical strip over here, what happened? X and y still can moving around 0 to 2. But when I refer up, I see another line. It's not the same like just now. I see another line, which is x plus y equals to 4. And when I refer down, yes, I see the same line. So what you can see over here is, okay, you will see different things when you are in different region. So how I'm going to define the interval? Okay, if you face this problem, meaning that you have to split, okay, you have to split your region into 2. Okay, the one at the left hand side, okay, the y will be from y to x. No, the y will be from x to 3x. And the one at the right hand side will be from x to this one. You have to split it out. When you split out the y, okay, you have to split the x too. Okay, you cannot use 0 to 2 anymore. You have to stop here. X equals to y. Stop at these positions. Okay, so why is these positions? Okay, so this position is the intersection point between y equals to 3x and this one. Okay, so now you have to solve for this point. So taking x plus y equals to 4, and you replace the y with 3x because it's intersecting with the 3x over here. So it's x plus 3x equals to 4. So your x will be equals to 1. So this position will be equals to 1. So for region at the left, you will be swapping from 0 to 1. And region at the right will be from 1 to 2. Okay? Now you split it into two regions. So when you write down over here, okay, you have to write this way. First of all, let me write down the dx. The dx for the right side, sorry, for the left side will be from 0 to 1. And the dy, okay, will be from x to what? Check. To what? To 3x. To 3x. 3x. Okay, so this one is the region, okay, at the left. Okay, for the right, your dx will be start from 1 to 2. And the dy is from x to what? Look at the left. Okay, you see, 1 to 2. Okay, x to what? Okay, now you need to put your y at the left hand side because you are defining the dy. So it will be y equals to 4 minus x. Okay, put the y at the left side. Okay, so 4 to x. 4 minus x, sorry, 4 minus x. So this one will be the interval for the region at the right side. Okay, so when you are putting them together, you want to find the total area, right? So you have to write two sections. One will be section at the left. Okay, remember number, put it outside. And then followed by variable. So it will be x to 3x. Here will be equals to 1. Okay, so x to 3x belongs to dy. So dy you fill up here. And then the next one will be dx. This is the section at the left. And you have to plus the section at the right. Still, the number, put it outside. Variable, put it inside. 4 minus x. Here, still 1. Okay, so x to 4 minus x is dy. So dy first, and then dx. Okay, so now you have two sections. One section is at the left, the other section is at the right. Is that clear? Can you follow?
Yes, Doctor.
Yeah,
Can
right. So now we start to solve. Okay, 0, 1. So it will be 3x minus x dx plus 1 to 2, 4 minus x dx. I skip the step. Okay, so because when you integrate 1 dy, okay, you will get y. So when you replace the range here, so you will straight away get, okay, 3x minus x. Okay, so I skip the step. Now you can press calculator. So maybe here you want to simplify it as 2x. Here you want to simplify it as 4 minus 2x. Okay, you can press calculator now. How is it? Are you able to get this answer? It is 2 unit, 2 unit square. Okay, so I will move on to the questions D. Okay, question D. This time we try to solve using horizontal. Okay, question number D, 1D. So we have a line y equals to x over 2. Y equals to 2x and x plus y equals to 3. Okay, these 3 lines. So we sketch them like what I have told you. Okay. So by using the y equals to mx plus c, okay, you can know that this graph is going up. This graph is also going up. And if you rewrite this one, y equals to negative x plus 3, or this graph is going down. Okay, this graph is going down. And the m for this one is equals to 1 over 2. And the m for this one is 2. And the m for this one is negative 1. How about the c? The c is 0, touching the origin. And this one c also 0, touching origin. But the c here is 3. Okay? So for these 2 graphs, they will be touching the origin, but you will find that one of it will be more slanted. Okay? For the 2 one, it might be something like this. Okay? Okay? This one is y equals to 2x. Okay, I draw the other color. Make it spatial a bit. Right. So for y equals to x over 2, maybe like this. Okay. This is y equals to x over 2. Okay. So how about this? Negative x plus 3. So 3, I use the other color. 3 is here. 3. 3 is here. Okay. So what is its value if the y is 0? Okay, so it will be 3 also. So you can plot a line. Okay, quite similar to the previous one, right? Okay, you can find the regions. Okay, the region that is covered by these 3 lines. Are you okay with straight line drawing? Okay. Can you draw straight line? Straight line is very important, huh? Okay, huh? How about the others? One say okay.
Okay, doktor.
All right, make sure you can draw a straight line. Okay, right, okay, good. Okay, now we try to solve by using horizontal. Just now we try to solve using vertical, right? Now I try to solve using horizontal. Horizontal. So what color I want to use? Pink color? Okay, what's the which one? This one. Okay, now I form a horizontal line. Okay, so maybe my line is like this, horizontal line. It's over here. This is a horizontal line. Okay, so I can move my horizontal line to the top and to the bottom. So when I move it to the top, I will stop somewhere here, right? Top. Okay. And when I move it to the bottom, I will stop here. Okay. When it is at the top, okay, I have no idea what is the y. I need to find out. But when it is at the bottom, I know it is 0. Okay, I know it is 0. Okay, now let's find out what is the point Y here. So point Y here is the intersection point for the equation x plus y equals to 3 and also equations y equals to 2x. Okay, so if I put the 2x into the equations, so I will have x plus 2x equals to 3. So my x is equals to 1. Okay, so this is my x. I want y. Okay, so taking this x equals to 1 and replacing here, you will find that your y is equals to 2. Okay, so y equals to 2, 1. Then you get 2. Okay, so this is how you get a point over here. Y equals to 2. Now, I need to look at the left and look at the right because I need to define the dx interval. Just now I have find the y, okay? So when I look at the left, I see the red line, okay? Y equals to 2x. But when I look at the right, I see the blue line. I see the blue line. Will it be the same if I move my streak over here? It will be different, right? When I look at the left, yes, I see the red line. When I look at the right, I see purple line. It's not blue line anymore. So meaning what? Meaning you need to split it. Okay, split it just like the vertical strip technique. Okay, where you want to split? You have to split it here. Okay, so you have region at the top and region at the bottom. Okay, so when I split it, this means that my dy cannot stretch away from 0 to 2. I have to stop somewhere else here. The place where I split. Okay, so y, okay, coordinate here, okay, will touch purple line and also the blue line. Okay, you need to know why. Okay, what is the value of y? So solving the simultaneous equations, okay, by putting it, let me see what 2y, 2, you want to find the y, right? Okay, so replace it. So 2y equals to x. Okay, and taking the x here, 2y is equals to 3 and 2y is equals to x, right? 3 minus 1. So y equals to 1. Okay, I'm dealing with these two equations, solving the simultaneous equations. Do you know how to solve simultaneous equations? Or can you solve the simultaneous equation by using calculator? Are you clear about this one? How I'm going to solve and find the intersection point? Okay?
Okey doktor.
Boleh Can Okay, y equals to 1. So here meaning that it will be equal to 1. So one section, the dy is from 0 to 1. The bottom section. For the top sections, the dy will be from 1 to 2. Okay, 1 to 2. Okay, so let's write down the dy is dy. Okay, dy will be from 0 to 1. Okay, for the section at the top. This is the section at the top. So for the section at the bottom, you will have a dy, okay, from 1 to 2. Okay, 1 to 2 are clear. Now we go to the section at the bottom. At the bottom, we look at the left and look at the right. When I look at the left, I saw red line. Okay, red line equation is y equals to 2x. Now I want to find dx. Dx interval. So I have to rewrite it, okay, and make it to be like this. Okay, y over 2. Okay, so now my dy will be from y over, no, sorry, dx. My dx will be from y over 2 to what? To the blue line. Blue line equation is y equals to x over 2. But I need to define what is x interval. So x is equals to 2y. I'll just rewrite it. Okay, so now the dx is 2y. Okay, so this one is for the area at the bottom. Yeah, at the top. Sorry. Okay, now we define the area for the 0 to 1. 0 to 1 is so this one the palette. Okay, sorry, this one is at the bottom. This one is at the top. Okay, I'm sorry. Okay, top. Okay, now we define the area dx for the top. When I look at the right, I saw the red equation, so meaning that it will be y over 2. When I look at the left, I saw the purple equations. Okay, the purple equations. When I rewrite the purple equations, it will be 3 minus y. Okay, so 3 minus y. So it will be y over 2 to 3 minus y. Is that clear? Okay. Now we find the area. Okay, for the bottom. Okay, number we put outside. Okay, variable we put inside. Okay, always use this concept. Okay, here will be 1. Okay, so variable is actually the dx interval. Number is the dy interval. Okay, and then plus. Okay, now for the region at the top, 1 to 2, number put outside, variable put inside, middle will be 1. Okay, variable representing dy interval, dx interval, number representing dy interval. Okay, just plug them this way. Let's try, solve it, perform the integration with respect to x. You get 2y minus y over 2 dy. Okay, then plus 3 minus y over 2. You can simplify. Okay, if you don't want to simplify, you key in the whole thing in calculator is also fine. So let's solve for this. So 2. Okay, your calculator don't have y, so just you replace the y with the x. Okay, it doesn't matter. Okay, how is it? Can you get 1.5 unit square? 1.5 unit square?
Yes, Doctor.
Alright, so this is how you solve the problem using horizontal strip. And here I would like to share with you one question. Okay, so this is a question that I did with the section 3 just now. Okay, question 1b. Yeah. So for this question 1b, okay, if you solve by using vertical strip technique, you can imagine, if I solve using the vertical strip technique, I will draw the other line here. So meaning that is something like this, right? Okay, this is your axis y, axis x is here. Okay, if these questions you are going to solve using the vertical strip technique, okay, you have to split the region into two, right? Because you will see different line at different sections. You need to split it into two. But if you solve by using horizontal strip, okay, horizontal strip technique, you don't need to split it into two. You can just use the normal way, normal concept, okay? Look at the left, look at the right, and define the equation, define the interval to solve it. So when you are looking at one question, one region, always check, double check, which one will be easier for you, okay? I'm sure everybody you'd like to perform integration once only. You don't want to split it into two regions because you need to calculate 2 times. Okay, so every time you see a region, define, decide, analyze which technique you want to use, horizontal or vertical. Okay, if you use a similar or way, you see this one actually is a similar figure. Okay, so I have to split it into two. If this one I solve by using horizontal, I only need to solve it once. Okay, so you need to analyze yourself lah. Okay, you can look at the solutions yourself. Okay, and try it out. Okay, right. So that's all for today.